Hello and welcome to the Colorado Drought Conditions Outlook and Fire Risk webinar. This webinar is being recorded and the video will be made available on the NIDIS YouTube channel. My name is Joel Lisenby. I'm the Regional Drought Information Coordinator for the Intermountain West region at the National Integrated Drought Information System, or NIDIS, and you can find more information about NIDIS at drought.gov. I would like to begin by acknowledging the traditional owners of the land that we're meeting on today and pay my respect to their elders and chiefs, both past and present. As we are all in different parts of the country today, this will be different for all of us. My home office is at the NOAA Laboratories in Boulder, Colorado, and for me, the traditional owners are the Colorado Ute tribe. I would also like to acknowledge and thank the collaborators in producing this webinar. They are the Colorado Climate Center at Colorado State University in Fort Collins, Colorado, the Rocky Mountain Area Coordination Center, the USDA Southwest Climate Hub, and the National Oceanic and Atmospheric Administration. The format for today's webinar will be first presentations by two invited subject matter experts who I'll introduce in a minute. This will be followed by some time for some questions, and if you have questions, please type them into the question box. Our first presenter will be Dr. Becky Bolinger. Dr. Bolinger works at the Colorado State Climate Center. Becky got her PhD in atmospheric science at Colorado State University and now serves as the Assistant State Climatologist for Colorado. Following Becky, we'll hear from Tim Mathewson, the Fire Weather Program Manager at the Rocky Mountain area, and incident meteorologist. I hope I got that right, Tim. Tim's experience ranges from National Weather Service to the Department of Interior Fire and Aviation Branch. Tim is currently the Fire Weather Program Manager for the Rocky Mountain area. He's stationed in Lakewood, Colorado. Tim is responsible for providing written, graphical, and verbal fire weather information to a variety of user groups, including firefighters, fire managers, and the public. Additionally, Tim provides meteorological support on wildfires and prescribed fires as an incident meteorologist. And Tim says he has a PhD in experience. He will reach 30 years of service in January of next year. So congratulations on that milestone, Tim. Following Tim's presentation, Emily Elias, the director of the USDA Southwest Climate Hub, will facilitate the Q&A session. And again, please enter your questions in the chat box. So now, without any further ado, I will pass the webinar over to Becky. And you should have a presentation capability now, Becky.
Thanks, Joel. Does it look and sound okay?
Yes, you're good to go.
Great, thank you. So I am going to give a brief overview of the current drought situation in Colorado, how we got here, and what maybe is to come. First, we'll start with the U.S. Drought Monitor depiction of current drought conditions over Colorado. There is a table on the right that tells you how much of the state is in each category of drought. The yellow is the first category, which is not officially a drought category. It is abnormally dry. And after that, we go into the various levels of drought. We do have about 34% of our state currently in a D3 or extreme drought. Last week, we introduced D4 down in the Baca County, Prowers County corner, but that has since been removed. The area got about an inch of precipitation, so that D4 only lasted a week. But right now, we're still in a very concerning situation where 69% of our state is in some drought category, and over half of the state is in a severe drought or worse category. This is how the U.S. Drought Monitor has evolved over time from last year. So we started July without any drought or abnormally dry conditions. We had an excellent snowpack year last year, very late melt off of snow, and that really helped the region become completely drought-free, which was the first time in history that, in the USDM history, that we didn't have any of these categories in our state at all. But in August, we started to see a lack of monsoon moisture, and that led to some increasing drought conditions as we went into the fall. Through the winter, we had some D2 introduced, a little bit of improvement in the late winter, and as spring has come on, you can see that introduction of D3 conditions. And then this, you probably might not even be able to see it, but this tiny blip of D4 showing up here over time. Let's talk about our drought timeline for the state. I said earlier, it kind of started with the no monsoon. We went through an okay-ish winter, but then we transitioned into a very fast snowmelt and a warm, dry spring, and we've followed that up with a hot and windy summer. So looking at how that all started, this is soil moisture, which really starts off the cold season with how things are going to progress. It's your first bucket of moisture, and so if you start the soils off dry at the beginning of the cold season, that's a deficit you're going to have to make up sometime later in the water year. So when you hear me talk about water year, I'm talking October 1st through September 30th, which is really how we look at how things evolve. It evolved more naturally in that time period rather than the calendar year. So on the left is one soil moisture product we can see over the entire western United States, and that was as of the beginning of October. And then the one on the right is another soil moisture product put out by the Colorado Basin River Forecast Center. And it's just a way to they look at the start of fall and how soil moisture is laid out, because that's going to really dictate how water supply forecasts turn out in the spring. So looking at that beginning antecedent conditions of soil moisture in the fall is really important. And both cases we're seeing that soils were a bit dry, and a lot of that was driven by lack of monsoon precipitation in the late summer. So fast forwarding to spring, where we started to see a lot of warm and dry conditions. The upper left corner map is the temperature averaged over March, April, and May of this year. And then the bottom right one is precipitation averaged over March, April, and May of this year. And the color coding is representative of percentile ranking. So say you have 100 years in your record, if you're in the top 33rd percentile, that means for temperature that you had one of the top 33 warmest springs in that 100-year record, and 70 or 67 of the years would be cooler. So the upper left, where you have yellow, is in that top 33rd, and the orange would be top 10 rank in that 100-year record. So very warm temperatures throughout Southwest Colorado, through most of the state, a little bit closer to normal as we go into the northeast corner. For precipitation, the vast majority of the state was in the bottom 33rd percentile, which means 67 of the springs would have been wetter, and only 33 are drier. And then you can see some pockets of that bottom 10th percentile ranking, and even some patches of record driest spring showing up. So very warm and dry spring. And this is how it translated for snowpack. This is looking at the southwestern corner of the state, the San Juan Mountains, how snowpack evolved over time. The black line shows how snowpack was building up over those mountains from the beginning of the water year, October 1st, to a medium peak, which usually happens in early April. So the black line meets up pretty close with that green line in that circle there, showing that we actually did get close to a normal peak snowpack for this spring, which is good. But unfortunately, when you have a warm, dry spring and you don't add any new snow, instead of gradually following that green line down with a nice, slow and consistent melt, which is what we want to maximize the efficiency of using that snowpack, instead it very quickly melted out following that orange arrow, which has an impact on the length of the summer season and fire season, which you will hear about later, but also impacts the water supplies for our state. As we've gone into summer, we've seen a lot of high winds and hot temperatures, which has made evaporative losses really high. So what we're looking at on the left side is a product called EDDI, which is the Evaporative Demand Drought Index. And what this really means is we see evaporation coming off of our ground and our vegetation all the time. It's very common for summer to have evaporation. So this product says what is abnormally high or abnormally low evaporation. It looks at things like wind, temperature, solar radiation, and humidity. And from that, it said that in June, we had near record high evaporative losses from the ground compared to what we would normally see in the middle of June. And so you start with a precipitation deficit, which is bad, but then you add that the atmosphere wants to take even more moisture from the ground than what it normally does, and that quickly exacerbates a drought situation and puts even further stress on the vegetation. The little map on the right shows how quickly that evolved. Don't really pay attention to all those browns over the Great Lakes and Northeast region, but really hone in on Wyoming and Eastern Colorado, where you can see that we had very quick changes and increases in that evaporative demand with those brown colors. So it was something that came on very quickly in June and made the situation a lot worse. So if we package all of that together over a one-year period, the result is that we have extreme drought conditions across most of the state. And we can see that not just on the U.S. Drought Monitor, but at other drought indices that we look at. So the upper left, you can find on our Colorado Climate Center website, where we look at standardized precipitation index, which really takes the precipitation you get over a period of time and categorizes it for how abnormally dry and severe it is. And so anywhere where you see those oranges and reds and maroons, the 12-month standardized precipitation index is showing up as extremely dry. And we see that across much of the southern half of the state, most everywhere south of I-70. As you go north, some of the northern mountains aren't looking so bad. The gray dots are a little bit closer to that near normal range, but even the northeastern plains are seeing those dry conditions. On the right-hand corner, the bar graph I'm showing you is it takes the precipitation and evaporation and packages it together into one index. And for the 12-month period, that red bar, the last red bar on the far right, is for our current 12-month period, which shows up as very dry, comparable to what we saw just 2 years ago in 2018. Not quite as bad as what you see for 2011, 2012, or 2002, but obviously a very concerning situation. What has this meant for impacts? Largely, we've seen a lot of agricultural-based impacts. So I've heard from a lot of different FSA, Farm Service Agencies, and Colorado State University Extension that we're looking at chiseled wheat that wasn't going to come out. Many grass fires, especially in southeast Colorado. There's been a lot of purchasing of hay, requests for emergency grazing, selling cattle, running out of irrigation water. So the picture on the upper left is the result of a grass fire and the pockmarked land that you see after that grass fire. Bottom left was earlier in the spring. That's a chiseling of wheat to keep it from blowing. And in some cases, the seeds that they planted didn't even really go in the ground. The wind blew them and the seeds ended up staying on top of the ground. And then the picture on the right is an irrigated field And you can see that even with irrigation, there are spots that are struggling early on that just couldn't keep up with the deficits, even with water. As we move longer term into drought, we start to worry more about the hydrology of the system and our water supplies. And right now, our water supply is still doing okay, but it didn't really get as much benefit from snowmelt as it normally would. So this is looking at Blue Mesa Reservoir, which is the largest reservoir in the state. The black line shows how the reservoir level changes, and then the color shading is basically that historical range of levels that we see over time. So the bottom shows each month, and you can see last year on the left side, it was extremely low at the beginning of calendar year 2019 as a result of the 2018 drought, but an excellent snowpack helped it rise to near its peak. So we almost filled Blue Mesa Reservoir last year, which is great. And you have a normal drawdown, which is very normal to see for the late summer and into the fall. And then we want to see that normal rise again. And we did see a little bit of bump this spring, but definitely not as much of a bump as we typically see, which means our levels right now are a little bit below that median range where we really want to see it in that green shading, but now we're a little bit low. So there hasn't been as much drawdown so far as there was in 2018, and there's more of a bump than there was in 2018, but it's definitely not as good as we'd like to see it. So where do we go from here? First, I want to talk about how important summer and fall precipitation are for the state. And one way we look at this in our office is by the contribution of that month's average precipitation to the annual total. So do you have a month where you're contributing a significant portion of your annual precipitation just in that 1 month? If you are, you're in those greens or blue colors, and we would call that more part of the wet season. And if you're brown, it means that that month doesn't really contribute very much to the annual total, and it might be more of a dry season. So this is starting off looking at June, and the eastern half of the state, June is definitely a part of the wet season. We get a lot of regular and consistent thunderstorms. But as you move over the Continental Divide, things start to dry out, and especially as you go in the southwest corner and the Four Corners, you can see that June is part of the dry season. Right now, we're in July, and you can see that dry season peters out a bit, but really the bulk of important moisture is falling east of the Divide, the Eastern Plains, and even in the San Luis Valley. Shifting over to August, the driest areas tend to be in the northern part of the state, northwestern part of the state, where they get probably about the least benefit from monsoon precipitation. And a lot of that wet season shifts more south. And the bulk of this can be from monsoon moisture that we're seeing coming up from New Mexico and Arizona and extending even into further into the Arkansas Valley than just the southern part of the state. And then things slow down a bit as we get into September. We start to get in a little bit of a drier time period around the eastern I-70 corridor, and we start to see a little bit more consistent moisture on the west slope. So let's look at what the Climate Prediction Center is calling for in their outlooks. The left outlook is July, August, September temperature probabilities, and the right one is precipitation probability for July, August, September. So right now, focusing in on that precipitation outlook, you will see a little bit of that tan, light brown shading over most of Colorado, indicating that the CPC is leaning slightly towards a drier than average signal, but there's not a lot of confidence to that. So I would say over the next few months that there is a lot of uncertainty with that precipitation forecast. But on the left side where we see the temperature forecast, we have a lot more certainty that we're going to continue to see warmer than average temperatures as we move through the end of the summer. So where's the monsoon? I'm sure everybody's asking. And it is coming, and hopefully it is coming for us too. So the monsoon starts in the southern half of the United States. It really starts in Mexico and then starts traveling upward through southern Arizona and southern New Mexico. The Tucson National Weather Service office has a monsoon tracker on their website where you can see how the conditions are moving along there. So in the graph, they like to show how the dew point at Tucson is comparing to their long-term average. And that green line denotes a dew point of 54 degrees, which they have defined as really critical for being the start of the monsoon season. So as we've moved into July, they've had a couple of days where the dew point has bumped up over that, but not consistently. It's dropped down. But you can see from mid-late June that we are on that rise, which means we're hoping that consistent monsoon moisture should be in the southern area of the United States very soon. And then we hope that it will begin its travels up to the north. Unfortunately, the last couple of years, Colorado has not had as much benefit from the monsoon as we've had previously. So we're hoping for a stronger showing of that monsoon this year. But with that, there's also a lot of uncertainty in what's forecast for the monsoon as it moves north. So finally, I wanted to look at, can we make up the deficits we've seen for this water year? And unfortunately, for a lot of our areas in southern Colorado, the answer is probably not. This is in Baca County, Campo, southeast Colorado. The black line, the solid black line, shows how the precipitation has accumulated there since October 1st, and that's compared to the gray dashed line, which is the long-term average. And currently, as of the July 8th observation, we are at a almost 7-inch deficit, or 36% of average there. And then all these little skinny lines after are, if we take everything that's happened in July, August, September previously and pasted it on there, what would that look like for the rest of this water year? And what it really shows is that there is no situation where we could take historical precipitation and get back to our long-term average. If we get average precipitation for the rest of the water year, we would end at 60% of average. Moving over to the southwest side of the state, we see something very similar. This is Mesa Verde National Park, where we're at about a 6.5-inch deficit, 51% of average. Long-term average, they end at 18.5 inches. They're not going to get even close to that. Most likely, they're going to end between that 10 and 12-inch range. And possibly worse if there's no showing of the monsoon. So to not be a total Debbie Downer, I decided to show Boulder as one of our decent spots in the state where that black line has been tracking above the long-term average for almost all of the water year. And even if they dried out, they're very likely to end the water year near or above average. That is it for me. And I hope that you found it informative, and I'll answer any questions at the end that you may have.
Thanks, Becky. Thanks for your talk. I'm going to hand over now to Tim for him to talk to us about the drought and the fire weather. Okay, Tim, you should be able to share your screen now.
All right, Joel, how's that looking?
Looking great. Thanks, Tim.
All right. Well, good morning and good afternoon, everyone. We have folks across the country. Becky did a great job outlining the drought conditions. I'll have some similar graphics, but I'm going to tie those graphics and that information into the fire environment and talk more about the fire environment. Then at the end of this, I'll have a couple graphics showing our outlook for July and August, and we can talk about the fall as well if you want, if we have time. But I'll go ahead and get started. And one thing I like to do, let's see here, there we go. We'll start off by taking a look at Colorado fire history and fire seasons. I think having some understanding of our fire seasons, when they happen, when they don't happen, is very important. It gives us kind of a baseline here at the Rocky Mountain Area Coordination Center of how we're tracking compared to average. So I'll talk a little bit about that. I'll briefly get into the fire environment, and I'll talk about conditions and seasonal severity, some of the variables that we look at heading into fire season, what they mean for the fire environment, how we're kind of sitting this year. I'll talk about the Drought Monitor a little bit, some of the drawbacks of using Drought Monitor for predicting fire in fire season. I'll give a couple examples of that. We'll talk a little bit about short-term weather patterns and fire season outcomes, a little bit about the southwest monsoon, then I'll show you some prediction maps as well. So this graphic shows a number of large fires, January through December. It's about a 20-year record. Before 20 years, the record's not very good. So we focus on the last 20 years, and these are number of large fires. So basically 100 acres in timber, 300 acres in grass. And one thing we can see across Colorado, we have three pretty distinct fire seasons. You can see an upward tick March and April of fire occurrence and large fires. We call that the pre-green season. So before we get into green up, that's when we're starting to warm up in the spring. We start getting more wind events in March and April, and we can get large fires. A lot of those large fires are contained in the lower elevations, the plains, some of the lower foothill regions. We'll see those large fires, and 99.9% of those are human caused, unfortunately. Then we see kind of a downtick as we green up in April, May. We usually get a little bit wetter, just really depends on the year. But by the end of May, we start to see an uptick in our fire occurrence, especially over southern Colorado. Then that moves northward over time. And we typically peak out about this time of year. So our core fire season's really late May through about August. And really the severity of fire seasons really dependent on how strong the monsoon season is. Once the monsoon begins, we start seeing a decrease in large fire occurrence. Then we move into fall and we start getting into dry cold fronts. Dry cold fronts typically bring wind. And unfortunately, those fires too in the fall are usually human caused as well. Statistically, about 75 to 80% of our fires are from human, and the other percent is natural, so lightning. Human ignition can be sparks off brakes, heavy equipment, cigarette butts, those type of things. Just burning trash in the yard. We've seen trains spark fires as well, so just a variety. So when you get into July, you're seeing a combination really when we peak out of the onset of the southwest monsoon, which typically brings a lot of lightning. And then we still have that human component, sometimes from camping, leftover campfires, and so on. So 3 fire seasons, which we're in the core fire season now. That's where, our summer or our hot season, that's where we see the most fires. Our biggest fires in Colorado history have occurred in the first 2 weeks of June. The reason being is we're typically still very windy late May into early June some years. We can see significant wind. That's been the case this year, where we've seen significant wind in early June and mid-June, and in some cases late June this year. But our largest fires in Colorado history have occurred in early June, and a lot of that's again from wind and hot and dry conditions that develop prior to the monsoon. It's kind of a pre-monsoon window there that we talk about when we're talking about fires. Unfortunately, some of our biggest fires in Colorado history have also been human caused. We can look at the Hayman fire, for example. Fires do increase in size as we get into July, as lightning occurs. But again, we start to get away from the big wind events when we get into July. The weather pattern typically doesn't support it. As you can see from that graphic too, those bars, they're in every month. So we have large fires in every month. It's just the winter months and the late fall typically are not that active, but they're usually confined to the lower foothills and the eastern plains, and those are all human caused. We've had fireworks fires in January before on dry, windy days. So knowing a little bit about our fire season and historically is very important. And I'll briefly talk about, what average conditions typically look like, then above average. So Becky talked quite a bit about this, but usually we see, moist conditions, increasing snowpack, March, April, May. May is one of our wettest months, especially along the Front Range of Colorado. So the wet season should be wet. And then we start to dry out at the end of May in southern Colorado into June, and early July can be dry as well, just before the monsoon begins. And then July and August, we usually see a downtick in our fire occurrence, so we can still have fires, but the severity does change as we get into our wet season, which is associated with the North American monsoon. When we're talking about above average fire seasons, there are some characteristics and common themes with that. March, April, May typically are dry, hot, windy. Some of our bigger fire seasons like a 2002, 2012, and to a certain extent 2018, very dry, warm, windy conditions during the spring. And so the wet season, or the typical wet season, ends up being dry, and it kind of sets the stage for above average fire conditions and fire potential. But sometimes even during those worst fire years, we start to see July and August get a little bit wetter. It mitigates that fire season a little bit. But usually the damage is done by mid to late June. We have a lot of fire on the ground, and the busy fire season has already occurred, really. So I'm going to talk to you a little bit about the wildland fire environment factors. I'll get into more of the fuels and impacts of drought on fuels and the fire environment. And I'll talk a little bit about fire weather as well, and then we'll get into the outlook. So the fire behavior triangle, we look at weather, fuels, and topography. So when all of these come in alignment, we can have large fire growth. We've seen that here in the last few days across Colorado. A lot of moving parts this morning in the Rocky Mountain Center with moving aircraft, fire crews around in Colorado and all the way up into Wyoming. We had some fires the last 24 hours. So we're going to talk a little bit more about fuel moisture. I won't get in deep into the definitions or anything, but really drought and impacts on the fire environment, specifically fuels. And then we'll talk a little bit about the fire weather component and probably stay away from the terrain stuff. So Becky already showed quite a few maps here. This is a precipitation anomaly for June 2020. And as Becky already mentioned, we had a very warm, dry, windy spring. April snowpack, at least going into April, wasn't too bad, and I'll show you that here in a second. But after about mid-April, things really turned another direction. But dry across much of Colorado and eastern Wyoming, South Dakota, which started obviously in the spring, and it raised concerns early on about what type of fire season we were going to experience. This is the temperature anomaly for June, so very warm and dry conditions. That was coupled with a lot of wind events, and I'll talk more about the wind events here shortly. In terms of snowpack, April 2019 snowpack, that's the graphic there on the left. April 2020 snowpack is on the right. This year we weren't doing so bad April 1st. We were close to the average. In some cases, we were above average for snowpack in the northern mountains. It changed rapidly after that. Last year, we had so much snow at times we were closing ski areas in the spring, and we had a lot of avalanches. Snowpack's very important in terms of fuels, and I'll talk more about that. But things weren't looking too bad heading into at least April this year. And then late April and May rolled around, and we had the hot, dry, windy conditions that Becky alluded to, and we had early depletion of snowpack, and we were not adding snowpack. So those factors there played a big role in losing our snowpack very early. And the graphic there on the left is May 1st, 2020 snowpack. Those red and yellow areas indicate below average. And then the one on the right there, June 1st, below average. So